Hello. So right now we're going to be going over problem 5. I've signed an NDA. Here we're going to create some or implement some class that takes in a dimension D and a width W, where it wants us to create D-dimensional arrays uh, with each array being of size W. So we have this class. Let's take a look at what's going on. We're passing in here, as we saw, the D and the W, and we keep track of the dimension, and we also keep track of the value. So say I give some dimension D where it's 0, right? If the D dimension is 0, then we'll just have one object of ND array where we have access to just dot value, right? We won't have access to any other dimensions, right? Because the dimension is going to be set to, well, 0, right? So we don't need to do any of this other code, right? This is the most basic case we can possibly get. So if D is going to be equal to 0, then we just want to return, right? We don't need to create any nested arrays. Now, let's look at a case where maybe D is not equal to 0. Well, let's say I give you some D is equal to 2 and some W is going to be equal to 3. Then the resulting array should be of size 3. And within each of these arrays will be another set of arrays. Right? Of each size, again, 3. These are just commas I'm displaying, just to show you how big the nested arrays are. And yeah, we have to do this D times, right? Because if we have D dimensions, well, we have to, right now, we've created a 2-dimensional array of each array being size 3. So let's go ahead and start implementing this. So array is going to be set to a new ND array that takes in, as we saw over here, our width of our outermost array has to be of size W. Now for each element, right, what did we do in our example? We, well, gave it another ND array of size W. Now, in order to do that, we have a for loop. So int I is going to be equal to 0, right? We want to initialize each element of the length W array. So I is going to be less than W, and then I plus plus. Sorry, these are semicolons. There we go. Now, say the D dimension was 2, then the dimension when we're in this array should be 1 less than that, right? Because the dimension of this is just 1, right? If we blow up this array, this one element, we'll just have an instance of ND array, ND array, ND array, right? This will happen D times. And notice that we wrote our base case to stop when D is equal to 0. So let's go ahead and continue implementing our for loop, right? So for the for loop, we said for each element in our current array, so array at I, we wanted to set it equal to a new instance of ND array, ND array of D minus 1, right? The dimension decrements every time we create or recursively call ND array. And the width, nothing changes with the width. The width stays the same for all arrays. Great. So this will recursively call this, right? And our final array will be of dimension 2, right? So as we have illustrated over here, we have a 2-dimensional array, each of size 3. And when d is equal to 0, we're just going to have an ND array instance with no array, right? The array will be null when we hit this base case. Great. So that was part A. Now let's go ahead and take a look at part B. In part B, they ask us to implement some sort of get method that takes in a list to help us index into the array. So in this case, 0, 1, passing that as chords should return 4. Now, how do we do that? What we do at first is we take the, we take the 0th, oh God, we take the 0th element, right? We take the 0th element of the chords, and we go ahead and see what that value is. That value is 0. So we're going to go ahead and index into our outermost array right now, and we're going to ask for the element at 0. The element at 0 happens to be another ND array of size 2. And so now we have to do this step all over again, but this time we're going into the next dimension, right? So now we have to look at the next element of chord, which in this case, it's going to be 1. And we're going to index in this blue array that we have highlighted. Oh no, didn't mean to erase. We're going to go ahead and select the first element of that, right? And the reason we have 4 illustrated there is because 4 is represented by this dot value instance variable in ND array. So that's what we're accessing in get. Let's go ahead and start implementing. I'm going to start with the recursive case. So if the array, or so we're going to return the array at index. So index here is the 0th element or the next element of chords. And what do we do here, right? What we did in the very first step was return this blue array that we have up here, right? This nested array at 0. So after that, we recursively got this next element of chord. So we're going to call get on chord sublist, passing in 1 and chords dot size. What does this do for us? This essentially creates a sublist of the original chords that we had, right? So if we had the chords being 0 and 1, we will now recursively call it on just 1. And now the array, the array that we're recursively calling it on is the blue array that we have highlighted over here. All right, the blue array that we have highlighted over here. So then we're going to index into the green, right? The green representing that ND array. Then we'll recursively call on that ND array with a sublist of nothing, right? We found the ND array at element 1, and we're going to recursively call it on the sublist of an empty chord. So what happens now? So now we should probably implement our base case. So if chords is empty, if we have no more elements, if we have no more elements to recursively get, right? If there's no more dimensions that we have to get through, then we just want to return the value, right? So when we recursively called on this green part, our chords is going to be empty, right? We access the green section using this one. We will return the ND array of green, right? And this ND array has a dot value. As we saw earlier, it has this dot value over here. And this dot value for us in this example will be 4. And so eventually we will return 4. And yeah, that was part B. I hope that was helpful.